In this test, we're going to use a z-test calculator in order to perform a z-test, or also known as a normal deviate test. Now, this z-test calculator you can download yourself in the link that's in the little description of this video if you don't have it already. Now, in this example, we're looking at a college group in a church. So it's a group of college students that meets together every week for Bible study and worship and other activities. And they meet on Sunday mornings. And this college group's long-term average attendance is 100 with a standard deviation of 10. So that means that there's usually between 90 and 110, and almost always between 80 and 120. They have a big outreach activity that they use to attract more people to the group. And then afterwards, they measure the attendance on 4 Sundays to see if the group has grown. And the first Sunday, it's attendance of 100, no change. Second Sunday, 105. Next Sunday, so 105 is a little bigger. Next Sunday, 95. And then on the fourth week, it's 120. And so it looks like on the average, it's higher than 100. But is this enough evidence to conclude that the group has really grown? That's what we want to find out. Is this enough evidence? Now, the way that we're going to do this is with a normal z-test, because we have a sample of 4 Sundays and we have information on the population. Now, the population is whatever here it's the group attendance, whatever the statistic is that we know that's true for the whole population, and we want to find out if our sample is different from it. So our sample average is 100, or population average is 100 with a standard deviation of 10. Let's start off by clarifying what our hypothesis is going to be. So we're basically hypothesizing that the group has grown, and we want to test to see if that is true. So our hypothesis is going to be after the outreach activity, the college group's attendance is higher than the long-term, what we're calling the population average of 100. So we're hypothesizing that it's bigger now, that it's gone up. And the way that we're going to do that is with a z-test, where we compare the mean of our sample to the long-term population mean. And rather than doing the calculations by hand, we're going to use a z-test calculator. Now, you can find z-test calculators online, or you can download the one that's in the link in this video. That's what I have over here. I am just going to highlight the area that I want to copy into my prompt here. Now, when you download this, you could just type directly into the file and save it with a new name. Here I'm copying it into the prompt so it's all together. And so we've got the z-test calculator now, and we want to fill in the information. Now, the variable that we're looking at is attendance. And we have the calculator is filled in with generic information of 1, 2, 3, 4. We want the attendance is 100, 105, 95, and 120. We also need to put in what the new population mean is. That's 100. Then we want to put in the population standard deviation of 10. Now the sample size is 4. It's already 4. So now the calculator has calculated a lot of things for us. First of all, it calculated the new X bar, the average, and it's 105. So the attendance for these 4 Sundays was 105. We want to know if we can be sure that's different than what we would get if the group had stayed the same. Well, our z is 1, and our p-value, we want that to be low to show that it didn't happen by chance. It's actually 0.159 because we're making a one-tailed test. I should have actually put that up in the hypothesis that this is a one-tailed test, because we're only checking to see that it's grown one tail. we should always specify in our hypothesis before we do the data, one-tail test, whether it's one-tailed or two tails. And the way that we formed our hypothesis was that it was one tail. So our p-value is 0.01159. So that's like there's a 16% chance that we could have gotten an average of 105 in any 4 Sundays. So now we know that this p-value needs to be less than 0.05 for us to conclude that the null hypothesis isn't true, and that we should that we found strong evidence for our main hypothesis. So we have to retain the null hypothesis. So how do we write this up in standard APA format? What we can do is we can say that the attendance of a college group was measured on several Sundays, and we can say n equals 4. We use a little n usually when we're writing up APA for sample sizes or a subsample. We could use a small or a capital N. And then we use a capital M for mean. Mean equals 105. Oops. Equals 105. And you put a space before and after the equals. So I didn't put over here, I didn't put the space after the equal sign, so I'll put that there. Okay. Let me keep the after and outreach activity. All right, so here I said what our result was. We took a sample of 4 Sundays with a mean of 105. Now I'm going to present the results of the hypothesis test. And it wasn't supported, so I'm going to say the hypothesis that the college group's attendance compared to long-term attendance patterns. And what are those long-term attendance patterns? That's our population data. M equals 100. Standard deviation, SD is the APA abbreviation, equals 4 has grown. So that was our hypothesis, that the college group's attendance compared to long-term attendance patterns has grown. And then I'll put this in the next line, was not supported. And to show that it wasn't supported, we put in the details here in parentheses. I have shift open parentheses. I'm going to put our z-score. So control I, z, control I, because we write statistics in italics, space equals space 1.00, comma, and then I'm going to do p equals 0.16, and p is in italics also, so I do control I, p, control I, space equals space 0.16, and specify that it's one-tailed, or we say one-tailed test, or we just put one tail, and close parentheses. So that's what we can conclude, is that the attendance of the college group was measured on several Sundays, where n equals 4 and the mean is 105 after an outreach activity. Let's spell outreach correctly. The hypothesis that the college group's attendance compared to the long-term attendance patterns has grown was not supported. And here's the population mean and standard deviation, our statistic, and our p-value, and we specified that we did a one-tailed test. So that's how you would report the results of this in APA format.